What if you could use your hands, your fingers to grab an object and feel its shape, the material it's made of, and even the power to manipulate it? Today I'm going to show you that all of that and more is slowly becoming a reality. Hey, what's up everyone? I'm here at Dexta Robotics in Shenzhen, China, and next to me is...
I'm the founder of Dexta Robotics, so we build exoskeletons and robotics related stuff. This one specifically is called Dexmo. It does hand motion capturing and force feedback, so it allows you to touch virtual objects in virtual reality and gives you force feedback.
Welcome to the future. So yes, I'm wearing it right now, and it's like a mechanical claw almost, right?
Yes, I call it the exoskeleton, but claw is correct.
Yeah, and it's pretty obvious that with these gloves you can get like extremely immersed. You can go really deep into the rabbit hole basically. But what can you do with this? Because this is not a gaming device. This is not
yet.
for
Yeah,
not yet.
Yeah, because
we would love to though, but not yet. So tell me more about what this is getting used for.
Well, so it's mainly used for enterprises right now. We have people who are using this doing simulations, in both surgical simulations or vocational training, where they have something extraordinarily complex. They have a machine and they don't want people to just walk in and fiddle around with it, so they can build a simulated environment first. Or say something that's highly dangerous or expensive, say you're building a plane, you're fixing a motorbike. You can do all of those in a pre-trained scenarios where you build a VR training thing and you put this in. So we have a lot of customers who are doing that, also in car industry. People who are building manufacturing lines and they're training their workers. But you know how it is. It's very difficult for somebody who never getting touched with this type of thing to understand the procedures. But when you build a virtual environment for them and they put on the gloves, put on the headset, they can kind of play them as if it was a game. But if something goes wrong, no serious damage is done, and they could replay them every time until they get the point, and they would know what to do, and then they'll be put on the real field work, and things are going to be a lot easier and cheaper for them. Yeah, so that's kind of what it was used for. If you're interested in more of this industrial use cases and how this could help your business, you can visit the website, which is dextarobotics.com, and you can send us emails. We're happy to talk to you on how this could help your business.
Yeah, it will be in the description below, by the way, so that might be useful. So that's good to know that it's for enterprises, but for also for now. But that's a good cliffhanger. I like that.
I do want to have this quicker and send this to everybody's hand, but the problem now is that the whole ecosystem isn't there yet, right? People have limited budgets for buying this, obviously, and this thing, with enough quantity, with the volumes going up, the price will definitely drop down. But that's kind of a mutual thing. It's not just we want to cut down the price. It also depends on how many people are willing to pay for this. So, I mean, we ask the people who manufacture this, we definitely want more people to get hold of it. But it really comes down to, what's the current situation in the market and what are the things that we can do with it.
And you're a gamer yourself, so you know what's coming.
Oh yeah, I know people want this. Yeah, we've been talking about this for a while. I think it might be better if you just try it for yourself. Do you want to go?
Yeah, sure. Sounds good. Okay, cool. Let's go. So I got my Dexmo gloves on. I'm ready to go, and now the calibration starts.
Yes.
Yeah.
So let's stay facing to the screen, and we have to go through the calibration process where you perform a specific set of gestures that we follow, and then the computer would know what your hand sizes are, and they would fit the model to your hand sizes.
It's looking at how far my fingers go.
Exactly. So let's do this.
The
pinch movement. Yeah. But with the rest of the three fingers upwards.
Upwards.
Yeah, like that. Yeah.
Oh, yeah.
Yeah. Good. So it's recording a set of movements of your hands and try to match that to the digital avatar hand of yours. So when you're in VR, it will look more realistic.
Nice. That was easy. That took like, what is it? 5
Oh, it was
minutes?
only 5 minutes. It's okay.
Easy peasy.
Yeah. So hand calibration isn't entirely necessary. There are two ways of doing this. One is that you pre-calibrate it, you save your data. Next time you don't have to do anything. So next time you just put on the gloves, select your profile, and be fine.
Yeah. So you can save your hands.
Oh,
basically.
obviously, yeah. And you can also pick a generic hand model, which that would help you to skip the whole tutorial.
Yeah, I see. Okay.
But this will be more accurate. Yeah. So if you move your right hand, maybe making a fist or something, try to raise your thumb, put your thumb up. Yeah, you can see how the VR is happening in real time. And if you close both of your hands, make a fist, you can see the VR is matching to your hands. Right, so open up. Let's try to put something in your hand. Yeah, so if you slowly close it.
I can feel it.
Yeah, so what's happening right now is the motors are kind of restricting the movements of the hand going inwards, of the finger going inwards, and it's providing a pushing back force on the fingertip. So what you're touching.
It does feel like I'm holding like an object or touching something that I can't see, but that is definitely there because I can feel it.
Yeah. And if you look closely, you could see how the finger are kind of arranged in a curved shape. So that kind of fits to what the physics is actually happening within VR. So if we go to the next step, where we change the sphere to a box, right? Open up. Can you open up your hands? Yeah. And then you slowly close them. You can see how the fingers are kind of more aligned than it was earlier on. Back then it was kind of a curve, now it's kind of a straight line. So the physics that's kind of changing within VR would actually reflect to the physical force feedback system.
Lego?
Yeah, it's a Lego block.
Okay.
That's kind of for showing that one finger of yours can kind of go deeper. Right, so this one goes further down, and those two are kind of pushed upwards because of the Lego bricks that's kind of sticking out. Okay, so next thing, open up. Next thing, it's a squeezy toy. But
are you serious?
Yeah, I'm serious. This is a very.
Does it also make a sound?
It's a very professional demo.
Wait.
Can we have the sound on, please? Yeah.
This is pure art.
Yes.
This is what VR.
We're built for in the first place.
Yes.
I mean, who doesn't want to squeeze rubber chicken within VR?
I could do this all day.
Me too.
I would only buy it for this little demo.
What this is doing is kind of showing you the variable stiffness that the motors are capable of doing. So what that means is normally when a motor is fixed in place, kind of stiff. But now what we did with our motor control systems, you can kind of input the stiffness that's required for this situation.
Yeah.
And because in the scene it's a rubber duck and rubber, tend to be kind of squishy.
Yeah.
So we transduce all of those squishiness into mathematical formulas and stuff, and then we use those to control the motors to regulate the current, and now you can feel that springiness coming out.
So they adapt to different materials.
Yes.
Ooh, this one is hard to.
Yeah, that was kind of what it was designed for.
There we go.
So basically, what we did was like we used different layers of stiffness in software, and that change of stiffness is sent to the motors, and the motors operate at that specific stiffness we ask it to.
Yeah.
And then by combining those, it gives you a old-fashioned switch type of sensation.
That is so weird. This is so strange. The heck? It's like what you see here in my hands is like a beating heart that I can't see, but it is there. Wow, this is impressive.
Thanks. Okay, so open up your hand, and now if we get the water to flow, that's what's happened.
Oh, that's amazing. That's amazing.
So by kind of connecting the virtual world and the real world using this force feedback technology, we can match what really happens in VR, and that greatly adds in immersion. So this is kind of a hand scanning situation. Imagine you're a spy in a whatever building that you need to break into, and you can put your hand on a hand scanner, and this is where the shock waves going through this way and that way.
Yeah, so I can feel vibrations too now.
Yeah. And what's cool about this vibration is that it doesn't only happen on your fingertips, it also happens on your palm. Yeah. So I think there are 7 points of vibrations that are going on. So when it goes this way to that way, it activates on this finger first, then that finger, then that finger, then that finger. than this way, or when it goes the other way, it goes like da 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 da. So
it's like a wave.
Yeah,
that goes through my hand.
This is my favorite demo. I love it. It really makes me feel like something.
So this is
what's giving you the tactile feedback.
So it goes from here and it continues to do that. Yeah.
And what's cool about this is that the motors actually are not in direct contact with the fingertip. So the shock waves propagates from here. This is where the motor actuation actually happens. So that was kind of the non-VR demo. And now let's go into VR and see how they work in VR.
Yeah, that sounds great. Let's jack in. Let's get into the rabbit hole. There we go. Okay. Yeah, that's good. I'm gonna scan my hand right now. So here we go.
Yeah. Hold it there.
Oh yeah.
There you go. Try to use your hand to kind of grab the rock and take it out. Let's see what happens.
Ooh.
When you go through the plasma, can you feel what's going to happen with it? Yeah. Yeah.
That.
So the force feedback disappears when your hands try to go out because it locks the rock from the facility. It doesn't work that way either. Yeah, there you go. Now you can take it out.
Yeah.
Yeah, nice. And you hold it in your hand. Don't do anything yet.
Yeah.
Don't do anything yet.
Oh.
Did you feel the pulling of the motors?
Yeah.
Yeah. So that's how we do the explosion simulation. Yeah, got it. And just use your left hand to get the rock, put it in the bottle. Yeah. Now you have to take the cap and stick it on top. Lovely. So this is a worn out battery. You can just throw them away anywhere.
Can I also catch it with my other hand?
Or not. It doesn't do its job. Yeah, there you go. Yay,
nice.
Hooray!
Nailed it. Okay.
Successfully
so this is the old battery. I don't.
Yeah, you don't need them. Just throw them away. And you have a new one.
Yeah.
Which is on the left. Pick that and just immediately put it back. Yeah. Yeah. Exactly. See, that was smooth. Push it back.
And
turn it. Yeah. Lock it. And probably take a step back.
Wow.
Yeah.
I wish I could do that.
Me too. But please don't. We would have to call the ambulance for you. Welcome back to reality.
Yeah, thank you.
How do you feel?
No, I feel good. This was nice. This was fun. And you know, it's work in progress, but I do see where you want to go with this, and
thank you.
I'm very impressed. Yeah, the accuracy and the way you can feel things. It's like I've never experienced something like that before, where it's everything together. You know, I tried other gloves, but not gloves where it's just a one deal package. Exactly. It's doing everything. Also, something that I want to highlight is that you see Vive trackers right now. Again, that's something that's gonna change in the future, right? Where it's like
Inside Out is kind of becoming the mainstream now.
Yeah.
And we were talking to Oculus early on, and they were very kind to say that if this were to be working with Oculus in the future, then they probably are willing to put their tracking system just on the back of the system. So we don't actually need this chunk anymore.
No.
If, you know, the company-wise, we will be working, if we were to work together. But to be fair, this is very light.
This is very light. Like, it looks very heavy, but it's not. This is pretty much a timeline of the Dexmo glove from start to, well, present.
Yeah.
Yes.
This one was actually built in 2014, and it was handmade by me. A lot of the parts were machined and then silver welded, just to kind of show off the concept that we can technically build an exoskeleton that goes on your hand.
Looks like a steampunk.
Yeah, that was kind of the feeling. But this one was extremely difficult to modify, as you would expect, because those were metal. So we kind of shifted to a more modern technology manufacturing this, which is 3D printing at that point. So I built this one purely on 3D printer that I owned, and evolved several times from there. We went through a lot of trials and errors. So we tried to build one with 16 degrees of freedom, so we can capture more of our hand motion, but then we realized it would make the thing a lot larger than it needs to be, so kind of cut it down to this glove form factor. But then this one doesn't give you enough data that you need to regenerate the whole hand, so it kind of goes all the way back. So yeah, a lot of trials and errors. And then this one is kind of the stable build. This captures 11 degrees of freedom of the hand motion, but it doesn't actually have the force feedback yet. We left spaces where we can fit the motors in, but back then we couldn't find motors that were small enough. And then this was the very first version of Dexmo that has both force feedback and motion capture being being integrated
and
into
it
one
starts to
system.
look like a finished product in a way.
Yeah, that's where when we first started to throw shells on it and make it in a way that it looks more sci-fi. So over time, we did a lot of iterations on the circuitry, on the controls, on the softwares, and also on the hardware. Those 5, even though they look quite similar to one another, but each one of them runs a different structural kind of system.
What is this?
This was kind of a collection of our motory systems. So at the very beginning, we started with some of the off-the-shelf components, which is like this cubicle thing, but it was too thick, and it doesn't really fit our purpose because when you put 4 of them on the back of your hand, you kind of couldn't close your hands. So we know that we probably need to build this ourselves, and we did. So we started redesigning the whole thing. We took this apart, trying to understand the different bits of it, and started to optimize this from this point.
You also said that to make this, you partnered up with another company that is actually very famous.
Yeah, I mean, they manufacture, they are one of the biggest servo manufacturers in China. They're called K-Power, and they supply their servos for companies like DJI's, Huawei's, and this type of big companies. And the founder was very kind that they kind of invested a lot of time and their resources on helping us to build this from this step and push us all the way here.
This is a very important piece of the whole glove. So yeah, there's a lot more to talk about. So let's just take another seat at these beautiful animals. By the way, why are these here? Like usually you expect to sit on something more
comfortable. I mean, this is comfortable.
It is, but it's a little funky.
Oh yeah, because that's the style. I mean, we're the engineers. We build creative, futuristic stuff. You wouldn't expect us to sit on normal chairs.
So this is also how you do business meetings?
Oh yeah. I mean, I like this environment where people sit down and they kind of stop being adults and they can actually talk like they're supposed to. Because engineers are the type of people who are basically bigger childs. So
something I was also wondering, this force feedback glove, with what headsets does it work? VR headsets?
Almost every VR headset, because VR headset is kind of like a monitor, right? So if it works with PC, then you can use any monitor you want. So Oculus, we're currently using the Valve Index. It also works with HTC, PSVR, everything.
So I could also use the Oculus Quest?
Yeah, obviously. I just need to attach the controllers on the both sides of the exoskeleton, so it can kind of let you know where the positioning tracking are for the hands.
And what about platforms?
We currently support both Unity and Unreal, so that's about 99% of all the VR gaming developing platforms.
So I'm going to ask a very mean question, but I think most consumers would react to it like that. Mm-hmm. Why is this Dexmo glove so big, and why does it have a claw shape and not something you would see in Ready Player One, like just a glove and that's it?
We get it asked all the time. I mean, first off, this is real engineering. It actually works. So it's a little bit more complicated than CGI. So if you take a look at this, when people are making a fist, this exoskeleton goes around the fingers, which is why we need this extra sides to avoid collision when you're making a fist. If you need force feedback, you would need a motor to generate torque. And it really comes down to how you arrange those motors to give the best experience. For example, if the motors were put here, then the torque can be generated that way, and then the other end goes on your palm, so it's more evenly distributed. But for most people would have imagined if you have a glove form and you have a cable going all the way on the back of your hand, which, like you mentioned earlier on, it would ideally make it smaller, but it will also introduce a lot of other problems. Say when you're making a fist, the cables would actually provide a downward pressure, right? Then and that's even that has a even larger magnitude than the one that's being applied on your fingertips. So you will feel very confused. But those are the type of stuff that you really need to be like doing this for 5 years to properly explain. There are reasons why we're doing this, and this is, I can responsibly say, as small as this form factor can be to make this thing do what it does now.
Yeah, and with this design, I have the freedom to still move my hands in a comfortable way, where I don't feel like I'm restricted, that I'm like strapped in and I can't go anywhere. So I think the claw actually makes me feel more, in control of still my actual hands and not by machinery.
We put a lot of effort to make sure that happens. I mean, I'm a roboticist, so I do a lot of robotic stuff, and in robotics there's this concept of degrees of freedom. So for a hand, if you observe clearly, I mean, the fingers goes both this way and that way. For the thumb, it goes that way, and that way. So we carefully make sure that every degrees of freedom of your thumb is being released in some form. So it's not locked. Because when we're wearing a mechanism, it's very common that the mechanism restrict your movements in a way, right? So we carefully design it in a way. So if you look closely on the thumb, we have 1 degree of freedom, 2 degrees of freedom, 3 degrees of freedom, so that it releases all the locks and makes you feel more comfortable.
Like you would use a real hand.
Yeah. So it shouldn't restrict your movement. Otherwise, people wouldn't want to put them on.
What about battery power?
Oh, for now it runs on around 4 hours, so it's moderately okay. And batteries are rechargeable, so you don't actually need to like swap out and swap in. All you need to do is put it on a charger.
I want to thank you so much for giving me a demo and also allowing me to get into the office and see what you are working on. It's very exciting,
Of course.
and I'm looking forward to what you're up to next. This is like constantly evolving, so that's great to hear. And hopefully I will come back here sometimes, or we meet each other somewhere at an event, because you are at a lot of events too, in the United States and China, everywhere. So yes, thanks everyone for watching.
Thank you.
If you have any questions, you can also drop them in the comments below, and be sure to slam a like on this video. And that's about it. Now it's time for me to sign off. And
thank you.
Yes,
thank you for coming and telling people about this.
No problem. And as I always say, and I see you all next time. See you in the metaverse. I like how it makes the sound when I do my outro. It's like beep, boop, beep, boop. Can you hear that? That's cool, right? Bye bye. See ya. Like Tony Stark in real. That's a bit too much.
Way more complicated stuff than I do, but
he doesn't exist. You do.
Thank you. But